What do Thomas Edison, Ludwig van Beethoven, Helen Keller, and Captain Kirk all have in common? They all have experienced hearing loss. They are in good company with 466 million people worldwide with permanent hearing loss. What if we could replace permanent with reversible? Chickens, frogs, and fish can reverse hearing loss by restoring ear cells. Can we uncover our ability to regenerate ear cells and restore hearing loss? The structure and function of the ear are closely intertwined. The ear captures sound waves made by vibrations. The waves propagate through the outer ear, middle ear, and into the cochlea in the inner ear. If we unroll the cochlea and look inside, we find hair cells and supporting cells. The hair cells transmit what we hear to be interpreted by the brain. The hair cells are seen here in red and the supporting cells in green. Hair cells are exquisitely sensitive, and with sensitivity comes vulnerability. Hair cells can be permanently damaged from antibiotics such as gentamicin, loud noises from earbuds, infections such as measles, and with age. Is there a way to regenerate these hair cells and restore hearing? Cells in the ear begin as a pluripotent blastocyst during embryogenesis, and they have the potential to be any cell. Like this plain donut could have any glaze and topping. During development, the cells specialize as in a chocolate glazed or maple glazed donut. Lastly, the cells further differentiate into their final cells. In the ear, a supporting cell or hair cell, a chocolate donut with green sprinkles, or a chocolate donut with red sprinkles. At the end of development, we only have these committed cells. If the hair cells die or chocolate donuts with red sprinkles are eaten, how could we replace them? We could do a stem cell transplant, but what if we can urge these supporting cells to help out? These cells have a dormant capacity to regenerate itself and form hair cells. They are resident progenitor cells which exist in many organs, including the ear. By pushing the supporting cell to an induced bipotent cell, it can reform hair cells and self-renew, mimicking the same pathway during development. Molecules that stimulate the Wnt pathway and transcriptional activation cause the supporting ear cells to regenerate. These molecules can make a non-regenerative organ behave in a regenerative way. Second, molecules that activate the Wnt pathway and inhibit the Notch pathway cause the supporting cells to differentiate into hair cells. These molecules act locally and temporally. Creating new hair cells may translate into new hearing for people who have hearing loss. The ear may be the frontier for opening the regeneration potential of several organs and tissues, including the eye, brain, intestine, muscle, hair, and skin. The possibilities are endless.